Test for phosphorus. The presence of phosphorus can be detected by fusing the organic compound with sodium peroxide. The formed solution is treated with concentrated HNO3 and an excess solution of ammonium molybdate is added. A yellow precipitate indicates the presence of phosphorus. Test for halogens. The presence of halogens is tested by acidifying a portion of sodium extract, that is NaX, with dilute nitric acid and adding silver nitrate. If a white precipitate is formed which is soluble in ammonium hydroxide, indicates the presence of chlorine. If a yellow precipitate is formed which is sparingly soluble in ammonium hydroxide, indicates the presence of bromine. If the formed yellow precipitate is insoluble in ammonium hydroxide, then it shows the presence of iodine. If nitrogen or sulfur has been detected, the solution must be boiled for a couple of minutes to expel HCN and H2S which interfere with the test. Qualitative analysis of organic compounds. Detection of carbon and hydrogen. Carbon and hydrogen are detected by heating the organic compound strongly with copper-2 oxide. The produced gases are passed through anhydrous copper sulfate and then passed into lime water in a test tube. If carbon is present, then it forms carbon dioxide which turns the lime water milky. The reactions are as follows. Carbon inorganic compound reacts with copper-2 oxide and produces copper and carbon dioxide. The produced carbon dioxide reacts with calcium hydroxide, which turns it milky, indicating the presence of carbon in organic compound. If hydrogen is present in the organic compound, then it forms water vapor, which passed over copper anhydrous sulfate turns it blue by forming CuSO4 5H2O. The reactions are as follows. Hydrogen inorganic compound reacts with copper-2 oxide and produces copper and water. The produced water reacts with anhydrous copper sulfate which turns blue by forming CuSO4 5H2O. Detection of other elements. Other elements such as nitrogen, sulfur, halogens and phosphorus in the organic compound can be detected by Lasigene's test. The elements in the organic compound fuse with the sodium metal. The reactions are as follows. When sodium reacts with various elements found in the organic compounds, then it forms sodium fusion extract. Test for nitrogen. On addition of ferrous sulfate to sodium extract, that is sodium cyanide, it produces sodium ferrocyanide. The ferric ions generated during the process react with ferrocyanide to form blue precipitate of ferric ferrocyanide. Test for sulfur. If sulfur is present in the organic compound, then it can be identified by the reaction of sodium fusion, that is sodium sulfide Na2S with sodium nitroprusside. Then violet color indicates the presence of sulfur.
Detection of carbon and hydrogen. The analysis of an organic compound is the first step to find the elements present in it qualitatively. The detection of various elements present in an organic compound is called qualitative analysis. Carbon and hydrogen are present in almost all organic compounds. Let us see the procedure of detecting carbon and hydrogen. Take the organic compound in a dry test tube and mix it with cupric oxide, CuO, 3 times its weight. Heat the compound strongly. The evolved gases are passed through a delivery tube containing a bulb with anhydrous copper sulfate. Then, it passed into lime water taken in a test tube. If carbon is present, it forms CO2, carbon dioxide gas. The carbon dioxide gas turns lime water milky. The reactions involved in this process are C plus 2CuO gives rise to 2Cu plus CO2 rise. CaOH twice plus CO2 gives rise to CaCO3 plus H2O. If hydrogen is present in the compound, it forms H2O vapor, or water vapor. Water vapor, when passed over white anhydrous CuSO4, it turns blue by forming CuSO4, 5H2O. The reactions involved in this process are 2H plus CuO gives rise to Cu plus H2O. CuSO4 plus 5H2O gives rise to CuSO4 5H2O. Expected questions from this module. 1. What is qualitative analysis? And explain the procedure of detecting carbon and hydrogen in an organic compound. 2. Write the equations involved in detecting carbon and hydrogen in an organic compound. 3. Explain the principle involved in detecting carbon and hydrogen in an organic compound.